We're going to look at multiplying and dividing rational expressions with this lesson. We're going to start by simplifying the following rational expression, so 2xy over y squared times 3y over 4x squared, and we're going to state any restrictions. Just a very quick refresher in case you need it. If we're looking at multiplying two fractions together, so such as 2 over 5 times 3 over 7, we multiply the numerators, and then we multiply the denominators. So this expression would be equivalent to 6 over 35. So in the rational expression we're dealing with below, we're going to practice a similar strategy. So we're going to multiply together the numerators. So 2 times 3 is 6 times x. Y times y is y squared divided by. So we have 4. We have x squared, we have y squared. And at this point in time, we're going to look to simplify this expression by looking for factors that exist in the numerator and in the denominator. But before we do that, we need to check to see if any non-permissible values exist before we do any simplification. So looking at our denominator, we cannot have this denominator be equal to 0, because division by 0 is undefined. So what values will cause that to happen? Well, if x were equal to 0, we would have our denominator be equal to 0. And if y was equal to 0, we would have the same issue with division by 0. Now that we have identified non-permissible values based on this denominator, we can start to do our simplification. So we have 6 over 4. They have a common factor of 2. So we're going to be left with a 3 in the numerator and a 2 in the denominator after those simplify. X divided by x squared will leave us with an x in the denominator and a 1 in the numerator. And y squared divided by y squared is equal to 1. Provided that y is not equal to 0. So you can see why it was important to list that restriction before we did our simplification. Okay, so what are we left with after we have simplified? In the numerator, the only factor that remains other than 1 is 3. In the denominator, we have a factor of 2, and we have a factor of x. And we can see that everything else has been reduced by dividing numerator and denominator. However, there are restrictions. X cannot be equal to 0, and y cannot be equal to 0. So note that even though this simplified expression does not contain y at all, our original expression that we started with did contain the variable y, and we are not allowed to have y equal to 0 in that original expression. So even though the y has been simplified out of our expression, we have to list it as a restriction, because if we were to use it in the original rational expression, it would cause division by 0, so it is non-permissible. So the final answer, 3 over 2x, with x not equal to 0 and y not equal to 0. Let's now look at our next problem. So we're going to simplify this following rational expression, state any restrictions, and this expression is a little more complex. So the first thing we're going to want to do is to factor the numerator and the denominator in each one of these fractions. So let's start with this numerator, c cubed minus 2c squared. So I can see that they have a common factor of c squared. If I factor c squared out of c cubed, I'm left with c. And if I factor c squared out of negative 2c squared, I'm left with negative 2. So this is c squared times the expression c minus 2. All right, let's look at this denominator now. C squared, subtract 4. Well, that is the difference of squares. So that's going to factor into c plus 2 times c minus 2. Okay, so there's the numerator and the denominator of our first fraction. Now looking at the second fraction, which is being multiplied, we have c squared plus 3c plus 2. So this will factor into c plus 2 times c plus 1. And now let's look at the denominator of that fraction, c squared plus 5c. So they have a common factor of c, so we can factor c out of that expression, and we're going to be left with c plus 5 if we do that. Okay, it's about time to simplify any factors that we have in common in the numerator and the denominator. But before we do any simplification, this is the point where we have to check for non-permissible values, because after we have simplified, we may no longer see the factors which cause them. So c plus 2 in the denominator, well, if c were equal to a negative 2, that factor would be equal to 0, and that would set our entire denominator equal to 0. So c equals negative 2 is not permitted. The second factor, c minus 2, so if c were equal to 2, we would also obtain a non-permissible value. And looking at the second fraction in this expression, we have a factor of c. So if c were equal to 0, that would set that entire denominator equal to 0. And c plus 5, if c were equal to negative 5, that would set that entire denominator equal to 0 as well. So listed off on the right-hand side, these are going to be the non-permissible values. Now that I have identified my non-permissible values, let's see how much we can simplify this expression. So I have a c plus 2 in the numerator and denominator. Those two will divide to give me 1, provided that c is not equal to negative 2. I have a c squared in the numerator and a c in denominator. C squared divided by c will leave me with c, provided that c is not equal to 0. I have c minus 2 in the numerator and denominator. They will divide to give me 1, again, provided that c is not equal to 2. And I don't see anything to simplify any of these other factors with. So the simplified expression would be c times c plus 1. Those are all of the factors that are left in the numerator, divided by c plus 5, that is the only factor that remains in the denominator, provided that c is not equal to, and again, we typically list these from the lowest value to the greatest value. So c is not equal to negative 5, or negative 2, or 0, or 2. Observe that by the time that we have simplified this expression, the only one that we can observe from our simplified rational expression is negative 5. However, before we simplified these factors, we also had negative 2 and 0 and positive 2 as non-permissible values. We always have to list our non-permissible values based on the original rational expression and not the simplified expression. So c times c plus 1 divided by c plus 5, provided that c is not equal to negative 5, negative 2, 0, or 2. Alright, so this was multiplying rational expressions. In our next video, we're going to take a look at dividing rational expressions.